All right, so let's talk about equilibrium in this model now. Equilibrium. Talk about it both graphically as well as algebraically. So our equilibrium condition from last module still holds. The condition for equilibrium, or the equilibrium condition, is that actual Y equals desired aggregate expenditure. And we talked about last week why that's true. Right, if Y was greater than AE, then kind of inventories are building up, and so we slow down production because we don't need to invest in more inventory, so Y would go down. If Y was less than AE, then our inventories are kind of falling, and so we have to invest more to replenish those inventories, which is going to push Y back up. And so that's why this AE equals Y condition must be true in equilibrium. So this is our equilibrium condition. Well, we've just said that AE equals capital A plus Z times Y. So let's draw out these functions again. Here's our AE, here's our Y, here's our AE function with the intercept of capital A, which was defined as being equal to A plus I0 plus G0 plus X0. And the slope was Z, and we kind of talked about what Z equaled just in that last board there. And so this equilibrium condition is the same as last week. It's this 45-degree line graphically. Every point along this 45-degree line, AE equals Y. So this is our equilibrium condition. And when our AE curve crosses, this equilibrium condition is where our equilibrium is. So here is our equilibrium level of national income. So that's what it is graphically. Well, we can solve it just like we did last week. And the way of solving it is going to be very, very similar. So if AE equals that, if we invoke equilibrium, so at equilibrium, Y equals A plus ZY. Y equals AE, so Y equals that. And then again, we're just solving for Y. Move this one over. So it looks like exactly the same as last time, but what's different is what's in that capital A and what's in that Z. So we can plug back what we've defined before, and if that was, remember, A, if you don't remember, you can just look at your notes. A plus G0 plus I0 plus X0, so all that autonomous part, everything that's in the intercept. And then remember, Z was B times 1 minus T minus M. So we're going to put all that in brackets because we're subtracting Z. And so this is kind of our Y0. This is our equilibrium condition here. So that's graphically what we're, equilibrium is where these two cross. And algebraically, we're just solving for this point. So this is kind of why we went over that. We redefined things in a certain way last week, because then it becomes we're kind of solving the same thing this week. It's just what's in that capital A and what's in that Z. How we've defined those terms is just a little bit different this week. But everything else, like the way of solving, is the same. Our equilibrium condition is the same.